Hello friends, today we'll be learning about how to design a microstrip patch antenna using the software High Frequency Structure Simulator, that is HFSS. Now starting with the design, we have to insert the HFSS design into our project file so that we can be able to see the design space on the screen. Then moving forward, to insert the different geometries and shapes into our design, we have to zoom out this screen. As you can see on the scale, it is quite small. So to have a considerable size of our design, we have to zoom out of the screen by holding Alt Shift keys and then dragging the mouse towards the lower side of the screen. Now, inserting the first geometry in the microstrip patch antenna, we have to understand that patch antenna consists of a substrate material which has a ground plane on the bottom side and a radiating patch along with the microstrip feed line on the upper side. So starting with the design, we will insert a box which is a 3D geometry as a substrate. So we will click on one of the corners of the axis and then we can drag the geometry in X and Y directions. Now nearing to the exact size or around the size that we require for the substrate, we can click once again so that we can increase the thickness of the substrate. Nevertheless, if the geometry is not having the desired dimensions, we can always modify the geometry by clicking on this create box option, and we will observe the position as well as dimensional values here. So we can change the values in this box. Now getting the desired size of a substrate, we have to insert a ground plane. So for doing that, we have to click on this 2D shape, drawing a rectangular geometry in our design. Again, starting from one edge of the design or of the substrate now, and then extending it to the other side or other corner of the substrate. It will be having the same size as of the substrate and it should be on the bottom side of the substrate. So we can confirm it by moving the geometry three-dimensionally by holding the Alt key and mouse left button and then moving the mouse. Now the next step is to insert a radiating patch. Again, a 2D geometry is taken and on to the substrate we'll design a patch shape, and as per our requirement, as per the calculations that we had done, we can change the size of this geometry also. First of all, its position should be on the upper side of the substrate, so we have to change this Z position to be at 1.6 mm as the thickness of the substrate is 1.6 mm. And then to change the size of this geometry in X and Y direction, and as well as to insert the field, we have to position it on the substrate well. Now the next step is to insert a microstrip feed line. So there are numerous ways to feed a patch antenna. We are using kind of an easiest way to feed and to control the impedance of the antenna. So again, starting from one edge of the substrate till the radiating patch, we'll insert a rectangular shape, again moving it to the upper side of the substrate and adjusting its dimensions as well as the position. Right, so it should be most of the time feeding the center of the patch. Now the basic geometry is completed. Now we have to excite the antenna, and to analyze the structure, we have to excite this feed line on one of the edges with a port. So we have to assign a port to this feed line. Doing that will enable us to analyze the whole antenna structure. So for that, as we can see, this edge of this feed line is on the XZ direction, right? So we have to change this alignment here, and then again we have to insert a 2D rectangular shape. Now the basic rule to have a port geometry is to have the size at least 3 times of that of width of feed line as well as towards the z-axis, it should be 3 times to the height or thickness of the substrate. So we can insert the geometry initially, and then we can change the properties of this geometry. So it should be at least 3 times in this direction and at least 3 times of that of the size of the substrate. So we can adjust the size over here of the geometry and also in the x direction, right? So we can see the geometry that we have created is almost in the center of the feed line, right? Now what we can do, we can rename all these structures so that we'll not be confusing ourselves if we have to change the geometry afterwards. So we can rename them by clicking one by one the geometry name. This is the ground plane, and the next one we created the patch, then the feed line, and then the port, right? Now we have to assign the materials to these geometries also. So for this, the substrate material, which is the most commonly used material, is FR4. So we'll assign that to this feed, ground and patch. All these 3 surfaces are actually perfect electric conductors. In practical scenario, they are copper layers, so we'll assign them perfect electric surface. And then this port has to be excited, right? So we will be assigning it a lumped port element. So the resistance should be 50 ohm, and then we have to create an integration line in this geometry. So starting from one corner to the other corner of the geometry, the integration line gets defined. Now moving forward, we have completed all the steps necessary in the design. Now the last thing left is to make our design ready for the analysis or simulation. So for that we have to create a radiation boundary or radiation space around the antenna so that it can be analyzed using the Maxwell equations on the back end of this software. So for that, again, we have to insert a box around this antenna. It should have the antenna inside it, and the dimension of this box should be good enough that it should be at least lambda by 2 distance away from the radiating surfaces of the antenna. So we'll assign the design of antenna box, radiation box, like that. It should be quite far away from the radiation surfaces. So to see the position of our antenna structure, we can click on this newly created box and increase the transparency of this box so that we can easily see if the antenna is well placed within the box. So finally we have to assign that this box is a radiation boundary box. So we have to just assign this boundary condition to this box. Now to confirm if everything went well with the design, we can check the design steps. So all the design steps are correct. Just the one thing that is required to set up the simulation is left, which is the analysis setup. It will be covered in our next video, the whole analysis part and simulation part, and how to plot different graphs and to analyze those graphs for the respective antenna structure.